And divide radicals. Here are some steps for you to look at. We're going to be talking about rationalizing the denominator, and there are two different types of rationalizing denominators. It's when you have a single, so monomial means single, then you just multiply by the special one, the one that's in the denominator. If you have a binomial in the denominator, then you have to think about special one is the conjugate of the denominator. When you multiply denominators, if you have that monomial, that's just inside stuff with inside stuff. If you have a binomial, then we get to use that fun cheater's foil. Then last step is just clean up the denominators. Check to see if you can cancel the numerator stuff. You must follow the rules for canceling. Alright, so let's get into doing some examples. So we have this quotient property. All it says is if you have a radical, you can split up into two separate radicals when you divide. So here's what we're talking about. So we have this big radical with a fraction. We can split it up as a separate radical in the numerator and a separate radical in the denominator. And notice those are both perfects. The square root of 144 you probably memorized now to be 12. And the square root of 25 is 5. Let's come over to example B. Again, we can split it up as the square root of 25 over the square root of 36. Hopefully you're memorizing now that the square root of 25 is 5, and the square root of 36 is 6. Alright, last example on this slide is the opposite, where sometimes it's nice to throw the radical back together as one radical, and now we have 500 over 5. Can you reduce 500 divided by 5? Yes, and you get 100. And then you should notice that the square root of 100 is 10. Alright, that's how you can divide. Now we're heading and doing some rationalizing. So we'll start this first slide is when you have a monomial denominator. Single denominator. You can't leave an answer like this with a radical in the denominator. So what we do is we multiply by its special one, this square root of 3. So my original problem looks like this. 1 over the square root of 3. Now we're going to rationalize this. We're going to take this square root of 3 and we're going to do it to both the numerator and the denominator. And now we multiply across. So in the numerator, 1 times the square root of 3 is 1 square root of 3. And then we multiply across again. Square root of 3 times square root of 3 is 3 squared. Do you have a simplification of the numerator or in the denominator? Yes. The square root of 3 is 3. And then in the numerator, you just have the square root of 3. So you've rationalized it. You've gotten rid of that radical in the denominator. Let's do one more of these examples. Part B. So the first thing we do is just I'm going to rewrite the problem. 3 square roots of 5. It's a single denominator, radical. So I'm going to multiply by the special one, square root of 5. So you do that both to the numerator and the denominator. Now we multiply across. So the numerator, 3 times 5 is 3 square roots of 5. And then square root of 5 times square root of 5 is 25. And then the square root of 25 is 5. And then you have that 3 square roots of 5 up on top. Alright, now we're going into binomial denominators where you have two terms. The rule for this is you have to multiply by its conjugate of the denominator. So I'm going to just rewrite this problem again one more time. 2 over 1 plus the square root of 3. Now I'm going to take this denominator and multiply by its conjugate. So we change that little sign right there to a 1 minus the square root of 3. So 1 minus the square root of 3 over 1 minus the square root of 3. I'm just going to go ahead and throw a parentheses here. Now we multiply across. Be careful on these. So I'm going to not distribute first with this 2. So I'm going to hope to see maybe that 2 will cancel out later. Now we get to use our fun cheater foil. Cheater foil says that when you take conjugates, you only have to worry about the first and the last only. Because the middle terms will cancel out when you multiply by a conjugate. So first is 1 times 1 is 1. And then square root of 3 times negative square root of 3 is negative square root of 3 squared. All right, numerator, I'm just leaving alone. Head down to the denominator. Square root of 3 squared is 3. All right, now 1 minus 3 in the denominator is negative 2. Here's the nice thing about this problem now. Because I didn't distribute this little 2 here, this 2 and that 2 can cancel out because they're multiplying. The 2 is multiplying the parentheses. So we're left with a negative 1 in the denominator. So I'm just going to bring that back up to the numerator.
Mike Simmerdackley, dial 3702, please.
All right, next example. Again, we're going to just write this problem again. Negative 4 over 3 minus the square root of 2. Now we're going to multiply by the conjugate of the denominator, the special one. So 3 plus the square root of 2. 3 plus the square root of 2. Now we're going to go ahead and multiply across. Numerator to numerator, denominator to denominator. So negative 14, 3 square roots of 2. Then denominator, cheater foil. So 3 times 3 is 9. Last, negative square root of 2 times square root of 2 is 4. Now let's see what can cancel. In that denominator, square root of 4 is 2. And then I have a negative 14 plus 3 square roots of 2, multiply. I'm not multiplying that numerator through on purpose. All right, so I'm leaving that numerator alone again one more time. Let's head down to the denominator. 9 minus 2 is 7. Now notice these two things right here. 14 and 7 can divide by 7. So I have a 1 and a 2. So I have negative 2 times 3 square roots of 2. Now I would say you should probably go and multiply that back through. So negative 2 times 6 is negative 6. And then negative 2 square roots of 2.